So today we're gonna begin lesson 3. What is heat anyway? Do you guys remember doing this little dance? Heat is the movement of thermal energy from hotter to colder places. I think you guys got it. When we do our experiment, we are gonna try to insulate our cup. The air inside the cup is gonna be warmer than the cold ice water around it. Agreed? Okay, so if it's warmer inside the cup and colder outside, which way is that heat energy going to travel?
The air inside the cup goes out to the colder.
Okay, but is the air moving or is it
the ice?
The heat energy?
Heat.
So the heat energy wants to move from the warmer air outside. And what would an insulator do?
It would travel slowly.
So it'll slow down this movement of thermal energy from the hotter to the colder. So a good insulator is going to slow that down? Yes. Okay. So we have to decide what materials do you think are going to be the best insulator for your solar oven. There's 2 cards on your table. So we're going to say insulator and 1 card and not an insulator on another card. These are the materials we're going to test, and I want you to examine them and think if they would be an insulator or maybe not an insulator.
We're done.
We have insulator and not insulator.
What usually happens?
Insulator is not insulator.
So you think that's going to be a good insulator? Yeah. We're going to test all the materials you guys just examined. Here is an example of felt. And I'm going to show you an example of what to do, and then we're going to start passing these out. So if you have flat materials, there's 2 of each. Do you see the round? Yeah. The round goes on the bottom. And then we're going to put the top on, thermometer inside. When I put my fingers inside the cup, it just feels like the air outside.
Yes.
What's a good insulator going to do?
It's gonna trap the heat inside.
It's gonna slow that down, not let that the air inside is gonna be warm, but that thermal energy is gonna try to travel out to the colder places. So we're hoping a good thermal insulator, there should be less change in our temperature. Only 1 person is gonna read the thermometer, and then 1 to 2 other people are gonna record, and it's gonna happen fast, so I need everybody focused. I'm gonna give you your cup, and you're gonna put the material inside of your cup. And on the line where it says the material we are testing is, write your material. You're testing flat foil, write it down. Every 30 seconds, there's gonna be a reader up here, and the reader has to tell the writer. I need the reader that has the felt, shredded and not shredded. Come up. Gently put them in now. Writers, get ready. Readers, give me a 0. Temperature, go.
80 degrees Fahrenheit. 77.
Get ready, readers. You're going to read again in 10 seconds.
4, 3, 2, 1.
Take your temperature now. 1 minute, 30 seconds.
72. Right here. 66 Fahrenheit. 5, 4, 3, 2, 1, 0.
3 minute temperature taken now. You guys did a great job. Your paper is your ticket out the door. Line up with your partners. So I wanted to congratulate you. The ice bath experiment was a success. It was wonderful. I looked at your data last night and everything looks great. So now we're gonna analyze the results. What I did is I took all of your results from your individual pages and we've put them on one sheet so you can see everybody's results from each material. The sheet that says class data that's in red, go ahead and take that out first. I want you guys to go through your data. You have the material, flat or shredded, and then the temperature change. Can you guys talk in your groups for a minute about each material and the temperature changes? What you think about that?
We started at 79, and then we ended at 68. So minus that is 11.
If we're trying to find a good insulator, would a good insulator keep the degrees? Would it go down fast or slow?
Slow.
Why?
Because it's holding that heat from getting there.
From what? Escaping out into the colder area, right?
And then
Okay,
the cold
so
is still there.
do you think that's a good insulator?
No.
Why?
Because it's 24 degrees in there, and it got a lot of heat going to the cold.
What I want to do now is look at all your numbers. I took all the total changes and put them on cards. And I want you guys to make kind of like a number line. So I want you to rank what you think is a good thermal insulator to a poor, not so good thermal insulator.
That one.
Is this wrong?
Yeah, also 24 goes with me.
It gets warm in here for the less, but when it gets more, it gets colder.
So when we're building our solar oven, we want to pick the best insulator. And when we're cooking in our oven, do we want it to be warm or cold inside? Warm. So an insulator is going to help keep the heat in. So the reason we did the experiment with the cup was to see which material would help hold the heat in our oven. Because when we send these to Botswana, do we want them to stay hot inside?
Yes.
Do we want them to have dinner?
Yes.
So we need to hold the heat energy inside. Think about the cup as your solar oven. We want to know what material is going to hold that heat in here. My friends, I have to take a break here. My friends, and maybe we could help them with this. You know how it was cold this morning? They totally forgot their coats. So I gave them some of our extra materials because they needed a jacket. Come on up front, guys. Hey, come on, if you guys would stand right over here. Thank you, welcome, welcome. My friends wanted a really good insulator. Do you guys want them to stay warm? Yes. Do you guys want to be warm? Yes. So we need a good insulator. We need to keep their body heat trapped inside. So we want the smallest change possible. So yesterday when we did our experiment, the flat foil cup, it lost 28 degrees. Are you cold right now? Are you cold? Yes. She's very cold. What would let less heat energy out of her body? What? You're thinking foam? How are you feeling, Miss Blackstock?
I feel just great.
You're nice and warm?
Warm, toasty.
Huh. So you think the foam was a good insulator? She's gonna stay nice and warm all day now, right? Yes. Oh, poor. What's gonna happen if Miss Bettis has a foam jacket now?
She's gonna be so warm because that number is bigger, and when it's bigger, it's letting more heat out, and that number is smaller, and it's letting less heat out.
Yes, you were right. Now, does anyone have any ideas what else we could use to keep poor Miss Bettis warm? Yes?
Shredded foam.
Oh, if we did shredded foam and maybe we could stuff it in her stuff it all around her and tape it up, do you think she would stay warmer? Yes. So I wonder, why don't we all wear foil jackets?
Yeah.
They're not good insulators, are they?
No.
So I think you guys are feeling pretty good about this now. I want to go around table to table and let you guys choose 2 to 3 materials to put inside our box. We're not getting the materials out and doing it today, but I want you to think about what insulator should go inside to let the least heat energy out of the box.
We chose shredded foam, flat foam, so shredded plastic, flat foam. It doesn't lose a lot of heat like all the others.
We chose shredded foam, shredded plastic, and flat foam.
All right, green table. Can you tell me what materials you chose?
Shredded foam, flat foam, shredded plastic.
So you're gonna put all 3 of those materials in there, in your oven, and they're gonna be, what's the word called? It's gonna help hold the heat in?
Insulator.
An insulator. Okay, first of all, why did you choose shredded foam?
Because it traps the heat inside. It doesn't go to the colder place.
Okay, so it's a good insulator. It holds the heat energy inside. So there was the smallest change with shredded foam. That was really great. I think we're ready. I think you guys have enough knowledge to choose a good insulator. Do you guys think you can do it?
Yes.
Say, I can choose a good insulator.
I can choose
If I were to do this again with the ice bath materials, I would give the kids lots of experience and exposure to the materials and really handle them and get to know the materials first. I highly recommend to new teachers doing the solar ovens project, when you get to the ice bath, prepare it ahead of time, like days ahead of time, put the ice in it and play with it a little bit so you make sure the cups are secure, and all the possibilities of cups falling over, you can solve those ahead of time.